Hey friends, today let's dive into something that feels futuristic but is actually unfolding right in front of us. Complex and accurate physics simulations to train robots in alien environments like Mars or the Moon. This is the kind of stuff that makes me feel like our generation is sitting at the intersection of engineering, imagination, and opportunity, where experiments once thought impossible are becoming everyday projects. Now, here's why this excites me. These projects succeed not because space is simple, but because in some ways it's less complicated than Earth. Sounds counterintuitive, right? But think about it. On Earth, if you're running simulations for a robot, you've got to account for humidity, atmospheric pressure changes, and random weather chaos. A robot in Delhi and a robot in Chennai will both face entirely different sets of environmental headaches. But on Mars or the Moon, the atmosphere is either thin or practically absent. That means fewer random variables to throw your simulation off track. Once you lock in the gravity and temperature extremes, the environment remains relatively consistent across the whole planet. It's like designing a video game level with one set of physics rules applied everywhere, instead of constantly updating the patch notes. Terrain, of course, is the big hurdle. Mars has rocks the size of small cars just lying around, and the Moon has dust so fine it clogs everything from filters to hinges. But that's where specialization kicks in. A robot built exclusively for low-gravity environments can handle these quirks better than any Earth-trained machine. Look at NASA's Perseverance rover. It was designed with suspension systems that can handle jagged terrain and wheels tough enough to avoid tearing apart like its predecessors. Or take China's Yudu-2 rover, which has been crawling across the far side of the Moon since 2019, tackling slopes and rocks in near total silence. These aren't just robots, they're like extreme sports athletes, custom built for alien gravity. What's fascinating is how much this overlaps with the skills of gamers. Sounds crazy? Let me explain. When you train a rover operator or even a drone pilot, you're basically teaching someone how to respond to feedback from a simulation. You're looking at processing delayed data and making quick decisions that could cost us millions if you mess up. That's not too different from someone playing Kerbal Space Program or even a tactical shooter where every wrong move punishes you. ESA actually experimented with this idea when astronauts tested robotic arms and vehicles using VR simulations that looked suspiciously like a high-end video game. Even private companies are leaning in. Boston Dynamics, famous for robots like Spot and Atlas, started with military funding, but now tests machines through simulations so advanced they almost look like game engines. And then there's NASA's Virtual Rover project, where they've built detailed physics-based environments to train both AI and human operators. Imagine being in charge of a rover on Mars through what feels like a super polished simulator. That's not just training, that's the job. The beauty of these simulations is how transferable the skills are. If you're good at understanding physics engines in video games, you already have a mental model of momentum, balance, and timing. That skill translates surprisingly well to guiding a robot on another planet. No wonder more and more institutions are recruiting operators who are not only engineers, but also comfortable with simulation-heavy environments. And let's not forget SpaceX's Starship ambitions. They're openly talking about building robotic systems to prep the Moon and Mars before humans set foot there. That means fleets of machines laying out habitats, digging trenches, and running supply chains. Training those robots in simulated physics environments isn't optional. It's the only way to avoid billions in wasted missions. Every time SpaceX runs a Starship landing simulation, it's essentially the same principle. Repeat, adjust, and refine until the robot becomes second nature in the alien setting. So where does this leave us? It leaves us staring at a world where the overlap between gaming, robotics, and space exploration is becoming less of a quirky coincidence and more of a career pipeline. Gamers already understand the logic of learn the map, master the physics, and adapt to the environment. Add some real-world engineering, and you've got the makings of the next generation of rover operators and space robotics specialists. The fact of the matter is this: I see a lot of opportunities arising in the development and operation of these robots, and they translate extremely well to the skills people are already acquiring in video games. The rules of physics may change when you leave Earth, but the rules of engagement, simulation, adaptation, and strategy are already familiar to millions of us. And that's what makes the future of space robotics not just exciting, but strangely accessible.